Meet Mike. He's a founder who recently vibe coded an entire enterprise-level application all by himself. He went from a blank slate to a fully functioning platform in just a few days. Building software of this exact scale typically requires a full team of senior developers, a $200,000 budget, and about a year of continuous labor. On the surface, the result is incredibly impressive. The app works, the processes flow smoothly, and Mike is preparing to ship this product to high-ticket clients. But right before launching, he makes a pragmatic choice. He hires a human security team to peek under the hood and check the AI's work for logic errors. What that team discovers is a chaotic black box infrastructure. The internal architecture isn't built with standard human logic, and it's hiding some significant underlying vulnerabilities. Large language models can write functional code at light speed. But deploying that unverified architecture directly to clients risks shipping critical security holes before a single user even signs up. The first issue the human auditors spot is a critical Google Maps API key that is suspiciously missing. The final codebase looks perfectly clean, but they know the app uses maps, so that key has to be stored somewhere. By digging through the project's history, they find a forensic trail. While helping set up the cloud servers, the AI leaked the API key publicly, then deleted the code containing it and simply moved on. You can't just run another AI security scanner to catch this either. Automated scanners only read the final existing text. They don't have the historical context to recognize mistakes made and then delete it in past versions. A clean repository doesn't guarantee a secure application. The models lack the object permanence to track their own past mistakes. The team then checks the app's login system. Mike instructed the AI to use Superbase, which is a secure, industry-standard service for managing databases and user authentication. Instead of connecting to that standard service, the AI took a detour, inventing its own new cryptographic layer from scratch. Having training data on cryptography, it defaulted to building it, bypassing standard security protocols, and creating an insecure backdoor into the system. When an AI tries to overcomplicate simple instructions to show off what it knows, it introduces significant, unnecessary vulnerabilities. The most alarming discovery happens when the team looks at the app's internal communication routes and finds that the endpoints are completely public. The AI successfully generated a standard security token check, but it completely forgot one crucial step, verifying the JWT issuer. It didn't check exactly where the security token came from. It's like a bouncer checking if a Plastid ID card is real, but never looking at the printed name before letting them through the door. This logic gap results in a total system compromise. Anyone holding a valid digital token from any other app on the internet could walk right past the security check and log straight into Mike's platform. The machine flawlessly executed the technical syntax of a security measure while entirely failing to understand the real-world logic of what it was protecting. Looking at a list of security flaws, it's easy to focus on the errors. But despite all of these mistakes, the AI still saved Mike an entire year of his life. This chart breaks down the new time economics of software development. Generating the app's foundation used to take months of labor. Now, even if the AI introduces chaotic bugs, spending a week fixing them still results in a massive overall time reduction. The software engineer's role is moving away from line-by-line typing and toward high-level system auditing. We've seen this cycle before. When easier programming languages were invented in the 1950s, they didn't eliminate programmers. By making the tools more accessible, they created thousands of new engineering jobs. As the cost and time required to produce raw code drops toward zero, the market value of human verification and logic mapping increases. This creates a specific opportunity for traditional developers, stepping in to audit and fix these vibe-coded applications before they hit the market. The daily workflow shifts. Instead of writing boilerplate code, developers are reading markdown files, managing the routes of different AI agents, and translating human logic into machine-readable structures. As more founders generate a year's worth of code in a single weekend, they create a proportional demand for specialists who can step in and secure the results. The raw speed of code generation is an advantage. The machines can build at lightning speed, but they will always need a human to tell them what they just broke.